Hi there. So earlier today I realized that I haven't been having any sound on the latest streams, which means that basically I have made a uh, long-winded explanation about the pipeline and everything, and no sound got recorded, uh, which means that there's just lot of video footage of me browsing the internet in search for DirectX 12 related topics and uh, uh, and a lot of coding and waving the mouse around without nobody really understanding what I've been doing. So that's fortunate, but hopefully in the end I will find the time and motivation to edit the streams a bit into maybe some shorter videos on how I made things. At least I might add audio to the last few videos. Yeah, but that's unfortunate. That's part of being new at streaming and not knowing what can go wrong. um, yeah, but if you have been watching me doing things in silence, you'd know that I built out several different components of our renderer. I've built out a shader wrapper. I've built out a root signature. I've built out a pipeline state object. And I've even implemented shaders, at least the start of shader programs. Yeah, and everything seemed to be working just fine. So that's great. Still a bit sad that no one really got to hear me blabber about. But yeah, here we are. So right now our system is able to create all the initial components and some support components and end out with a pipeline that describes how to render graphics. The next step is to implement something that allows us to use data in the pipeline. Right now, we can only hard code our pipeline with values, and we have no way to upload this information. So we can upload it to the GPU, but we cannot bind it for now. Our root signature is empty, so it cannot hold any parameters. Our pipeline has an input layout, but we do not upload any data. So therefore, we need, in part, something called descriptors, which are basically descriptions of how data structures are to be interpreted and how they are laid out in memory. It's basically something like a pointer and a range and how to slice the data. So it's basically just a way to interpret data. from continuous memory. Whoops. I think I got some stream feedback. I had a tab open with the stream for some reason. I turned on sound. Yeah. Oh well. So the next thing would be something like creating a resource, perhaps in shared memory, and loading it into our pipeline. And we could do a descriptor heap. I'm just considering whether we could do it. Nah, I actually think we need a descriptor heap. Let's do a descriptors and do a descriptor heap. So this will be a collection of descriptors of different type. We will have several descriptor heaps, one for constant buffers, one for I think we usually allocate on the on the no, I don't think we need the vertex buffer and index buffer view to be set on our yeah, our vertex buffer and index buffer just get separate views, but we do need perhaps we don't need the descriptor heap for now. Maybe we should just delete it. Because, I mean, let's say we do a set graphics root constant buffer view. So if we create a root parameter index, we can bind a constant buffer view. And then in our shaders, we can fetch it. In our shaders, we can fetch it. Let's see. Yeah, because whatever vertex we um, um, whatever vertex we pass in, we would like to transform it by a view projection matrix. What is actually what gives us the 3D um, field of view of sorts. It's like giving um, seeing every vertex in a scene through a given camera. We don't have a camera, but we can calculate a view projection matrix. I'm unsure whether we need the descriptor heap for now to get things going. Let's see. Let's see. Let's see. Uh, uh, row major. So the first number is row major, DirectX math, column major. Uh, hmm. So yeah, um, I'm contemplating. Yeah. Yeah. Mm-hmm. Let's see. I'm just looking into how to. Yeah, maybe we should use. Huh. I am getting a bit tired. I've been doing a lot of work today on this project. So I actually do think that uh, yeah, I'm contemplating whether to do a bit of math structures, or rather, let's see. So column major. So actually, so column major is slightly more efficient for multiplies. Yeah, so everything will get automatically transposed. I used to just transpose whatever I needed to transpose and flip it as this information says. So first the columns of the first column, then, and here we have first row, second row. Yeah. Yeah, yeah. Maybe I'm too tired to think straight. So I would like for us to at least start having a slot in the root signature for a value. So, or rather a data structure. And it's not the set graphics root constant buffer view. If we set our root signature parameter um, let's see. Yeah, we create a parameter which has the type of, let's see, which has the type of a D3D12 root parameter type constant buffer view, meaning a descriptor of a so-called constant buffer. which is visible to the shader, visible to all shaders. It will be the first shader register of this type. It's gonna be in the descriptor. And it will also have a register space as the first, and we'll have no flags. None. All right. Now we actually do have a root parameter. So let's see. Let's do something like current layout. 0 is equal to a ConstantBuffer view descriptor. Yeah. We create a descriptor for a ConstantBuffer. Let me see. Do we actually need? So temporarily in our render, we will create a struct called passData, which will store a float called test, and that will be 50. We will initialize a buffer. Wait a minute. Should I do it like this? I think that and if we, let's see, if we create it on the GPU, let's see. Let's see. I think we might actually do it on the shared. Let's just do whatever we want here. We will create it in this shared resource. Actually, I'm unsure whether we need that one for now. So we will create a shared resource with the size of the pass data. And whoops, upload and the 3D resource state. Generic read, I think. Wasn't that the yeah, generic read. And we create that. Let's do a queue of an upload for the shared resource. And an offset of 0. And let's create a pass data structure constant. And set constant test equal to 32. Reference the constant. And the size of the pass data. And let's upload it. Upload. Wait a minute. Yeah, it's not a destination buffer because it's in shared memory. I don't need to upload it. I simply need to get the shared resource and get the resource and map the sub resource into a void pointer map pointer, which is a null pointer, and we pass in the map pointer. We mem copy to our map pointer from our constant. Oops. And we make sure that all the data gets passed in, and we unmap everything. There we go. Yeah. All right. Now we upload our ConstantBuffer. Let's see. So get our graphics command list. And before we do any of these things, we set graphics root constant buffer view to our GPU virtual address. Let's see. Yeah, actually we should do padding. I think we will get an error from doing this. At least one error, because we're not actually we haven't padded the whole thing. A constant buffer should be wrapped around. No root signature has been set. Let's see. Ah. Let's see. I think I know why now. Because I haven't bound the root signature. Yeah. So our pipeline state object needs to have a method that is called bind root signature, and it has to take in a DirectX12 graphics command list pointer, and we set the graphics root signature to our root signature pointer. So before we can do that, we will do our pipeline state bind root signature for our graphics command list. There we go. Yes. So it's now it's out of bounds because we didn't change the number of parameters. There we go. We now have set a root signature with one parameter, and we bind our root buffer constant view, root constant buffer view to our pipeline, which means that we bind the address of this data structure which resides in this. And I think we got a new follower some time ago. Welcome. Poltino. I get the messages on my email. Since I'm still new to streaming, I'm unsure whether I should have my stream open. As you can see, I just opened it. Anyway, welcome. Maybe it's a long time ago you followed. Yeah. Let's see. I change this view, I don't know. If I change the that's the let's see. Oh wow. All right. The last thing we need to do is to um, we need to make sure that it actually gets the right size, because constant buffers need to be a multiple of 256 bytes. We won't be using we will be creating, yeah, I think not a class, but we do need both a CPP and header file for this. We'll move these and make a namespace called GXE utils and copy this namespace into here. And we would like to be able to calculate this does compile well. Just an unsigned int. We've been using that convention for now. Calculate constant buffer alignment and take in a constant integer of byte size, and we will let's see, this shouldn't change anything. So the byte size plus 255 and do a logical AND operator with the inverted two last bits of whatever the result is, or rather and do an AND operator this basically flips this value, which means that the last two bytes get kind of discarded, and it creates a mask for the AND where these the first two bytes will be 0 and therefore get cut off whatever the result of this is, which is the remainder after 256. So yeah, that's what we do, and that's how we calculate our constant buffer size. But yeah, I think we should implement this in the CPP file because we then won't have to bother with redefinitions and everything. It will be easier just to include a math. Let's see. Library. So when we create our constant buffer, we would certainly like to, let's see, sorry about that, calculate the real size of the buffer, since it has to be aligned by 256. So since we're in the GXE namespace, we can just do the proper alignment calculation like that. And we still upload our constant buffer. And we bind it to our pipeline. Yeah, the last thing we need to do is to create a way for our shader code to actually use the data structure that we've uploaded to the CPU accessible memory of the GPU. Yeah. I think we selected the correct shader language. We will just give an example of a way to bind the uploaded constant buffer. So first we will create a structure that on the HLSL side will mimic our information. It will always be padded in bytes of 4. Be mindful of that. Oh no. So we called it pass data in our C++ code. So let's just call it pass data here as well, since this will be what we're passing in. To bind a constant buffer of pass data type, we have to give it a name, and we call it pass data constant buffer, and we tell it that it's residing in the buffer register, which has the index 0. So remember in our root signature where we create a parameter at slot 0 that was a root parameter of type constant buffer view, meaning it's a descriptor of a constant buffer that is visible to all shaders, which is at the shader register, meaning that for constant buffers there are shader registers. For unordered access views there are shader registers, and for SRVs there are shader registers. So this basically means it has index 0, and you can do two-dimensional registrations, meaning that there's also a dimension called the register space, which we won't be using here, but you could do a specifier that told you which space we were using, for instance, space 1 or whatever. Yeah. So right now in our shader code, we can then access the data. Let's see. for instance, we should be able to call ConstantBuffer data test. Right now our code isn't really displaying anything, but yeah, that will be a way we can test it. Let's see, we do not get any errors. And if we compile and check our insight, NVIDIA insight, let me see. I just have to set up the copy the shaders for the release build. So I just simply copy the shaders into my release build directory, and then I do run the application in NVIDIA Insight, and let's see, root parameters. It doesn't really register here. It never really did for me, at least. Let's see, linked programs. You can see now we have our shader programs here. They're not really doing anything, but let's see, all resources are generic read buffer. As you can see, it has the size of 256 bytes, even though we only store a float in it. So our byte size calculation works perfectly. This is just an empty buffer. It is our upload buffer. We should really name these, which you can. Let's see. What do we... Shader profiler. So let's see events. If we look at our command queue, we see that we set the root signature and we bind it to the address of buffer location 2. Now, buffer location 2 is this buffer. So it should be bound. Now we just need to access it by actually doing a shader program. Let's see, what could we do each frame? What could we do? The pixel shader here. Let's try this. No. Of course I need some code here. Yeah, we don't pass any data in, so I guess it's hard to do anything. yeah, it's not gonna matter. Wait a minute. Am I building two different things or? No, I don't think so. Anyway, usually it complains that I cannot override it. Oh yeah. Let's see if we do a draw call. What would happen? Let's see. Okay. No pipeline state has been set. Ah. Yes. Of course. This does not only have to set. Oh my god, I love the debugger. Without the debug layer, you would be fumbling around in the DirectX API for ages. I've heard that's the problem with Vulkan, that it doesn't really have a nice debugging layer. A lot can be said about Microsoft, but alright, a lot can be said about Microsoft, but at least they have done a pretty good job with DirectX. Let's set a primitive topology. D3D12. No, just D3D. Primitive topology. A triangle list. Alright. Now our draw calls doesn't give any errors. We clear with a clear color of black. This might be a problem of not actually drawing anything. Let's see, it doesn't matter that. Yeah, maybe we need to upload the data first. Let's see, draw. This doesn't help, right? No. We still do not. It's probably not supposed to do anything. Yeah, but I think I'll be rounding off today's streaming. I am glad that I eventually realized that I was missing sound on the latest videos. It feels kind of bad having to redo them, but yeah, what can you do? Maybe we have to set a viewport before we actually see anything at all. Maybe if we set a viewport, we'll get let's see, just a moment. It seems like I could do a viewport fairly quickly. Let's do a viewport really quick. D3D viewport. Let's create a viewport. Let's preface this with test area and test area. And I calculate the viewport. First we get the rect of the window and pass in the handle to our window and store it in the client rect data structure. We set the viewport top, left, X to 0. We set the viewport top left Y to 0, so 0, 0 for the top left corner. We set the viewport to a width of the client rect minus the right minus the client rect left. We set the viewport height to the client bottom client rect top, and we set the viewport minimum depth to a float of 0, and we set the maximum depth to a float of 1. What on earth is going on? Let's see. We register the viewport. One, and I think it's the address of that. Let's see. Yeah. Okay, and we have to set a scissor rect as well. A scissor rect is just a way of cutting the viewport, so you can slice it. Scissor rects and number of rects. DirectX12 rect, which is what sysrect, reference that. And the left, the right, the top, the bottom, there we go. Alright, that didn't do anything, at least for now. Yeah, I think we might have to pass something in. Make the pixel shader color all pixels same color. Yeah, I think we won't be seeing anything before we actually process some data, but looking on the bright side of things, we actually got our render pass more setup, and we accidentally made a viewport and a sysrect, so at least we don't need to do that. And for now, we do not need a way to do a constant buffer view. Uh, let's see. Oh, I'm really close to. Nah, we need to do too much work to actually take the last few steps at towards actually rendering something. So for now, we do not need a descriptor heap. We do need a some data structures for matrices 4x4, preferably row column major, and to do and matrix by matrix multiplication and matrix transpose. Yeah. Um, data structures for vectors, especially float 3 and float 4 are priority. Yeah, I'll have a last look at HLSL semantics. Let's see. Object space. want to try something before I log out. This might not work, but nah. Nah. I'm simply too tired. Alright. We definitely got a step further. I don't think that this needs to be in the test area. It will be in our actual use code. There we go. There we go. There we go. There we go. Let's see. Yeah, alright. I'll be logging off for now. Have a nice one. Hopefully I'll be seeing you around. Yeah. Hopefully during the weekend we will get to actually render some 3D models, which will be hopefully entirely awesome. Alright. Hopefully I'll be seeing you around.